Alright, hey everyone. So this is problem 7 on the final review, and this is going to be the function deep map. And so we kind of went over deep map in discussion already, except that was in Python. This is now in Scheme. So I'm probably not going to go over too much on like how it works, but here's an overview of what's going to happen. And so we have a nested list. We might have like a bunch of nested lists, 1, 4, 5, 9. And so we want the result of this to be one like the list, except like each like element, even if it's nested, it's squared. So 16, 25, 81. And the way we go about this is if it's a list, if the element that we're trying to like call fn on, it's like you can't like call it on this entire list because it's gonna error out. You can't like multiply x by x, a list by a list. And so what we're gonna do is we're gonna like make a recursive call of deep map onto like nested lists. So if the element that we're processing, trying to call fn on, is a list, then instead of calling fn, we're going to call deep map. Because what's going to happen is if we call deep map on here, we expect it to like return the value. Oh, actually, I was underlining the wrong thing. If we call deep map on the value on the list 4, 5, with that like nested stuff, we expect it to return 16, 25. Because it's like gonna apply fn on each element, and if it's like a nested list, it's like gonna make another recursive call going in. And so now we have like the idea of like how we want to go about it. And so what's gonna happen is for scheme, we usually like want to process the car and then like make a recursive call to like the cooter of the list. And so let's say we process the 1, and we need to say, is that a number or is that a list? Well, if it's number, we're just gonna apply fn on it. So if it's a number, we're going to apply fn. But otherwise, if it's a list, then we want to make a call to like deep map on that list. And then once we got that number, we're going to make a recursive call of deep map of fn, so the same function, but it's going to be on the cooter of the list. So the remainder might be 459. That's what we're calling it on. And so when we do that, we're going to get that result, and we want to add whatever like we validate this is. So like the deep map call or like the fn call, we're going to add it back to like the beginning of that list. And so if you might imagine, the 1, actually let me just change this to a 2 so it makes more sense. So it's going to be a 2. fn is going to validate to a 4, and then like the recursive call, a deep map on the cooter, is going to return the list maybe for 16, 25, 81. And we're going to add the 4 back in to get our like final result. And so let's dive into the problem then. And so one thing to know about this is we also need a base case. And so we have 3 different situations. One is if the list is null, like if there's nothing else in the list, then we know that there isn't anything else to process. So in that case, we want to return nil, so an empty list. And so the condition, first condition is going to be if it's an empty list, then we're going to return nil. And oops. Yeah, so this is our first condition, our base case. And then now it splits into 2 situations. One is if the first element, so the 2, is a list or not. And the second is if it's not a list, so it's just a regular number. And so I'm going to move things up over a bit. And then so what we have here is another condition checking if it's a list. So we need to check if the car, the list, is a list. And if it is, then we need to make a recursive call of deep map onto it. And so we're going to have a cons because as I mentioned before, we're going to like get like some value and we want to add it back to like a recursive call. And so we're going to cons the deep map of the function applied on the car of the list. So the first element, and then that result is going to be added to like a recursive call of the cooter. And so the recursive call would be deep map of fn on the cooter of the list. And that's going to get us the list that we want. And let me make sure the parentheses match up. 2 more right here. Yeah, and so now we got that down, and then we need to handle the last case. And that's the case in which it's a number. And in this case, so like it's not a list, or it's like not empty. And so in this case, we want to, it's like a bit more simpler than a list. So rather than making a recursive call to deep map, we can simply apply fn on that number. Because that, on that first element of the list. So fn of car list, we're going to add that to like the remainder recursive call. So that's going to be deep map of fn onto the cooter of the list. And let's see how many parentheses I'm missing this time. 1, 2. Well, answer is a lot. But if you ever want to type this in into like to check if it like works, you might be missing a couple parentheses, so keep that in mind. But the general idea stands, and yeah, that's kind of like all of deep map. So if the base case is if it's empty, otherwise, like if it's empty, we're gonna return an empty list. Otherwise, if it's a list, then we're gonna like make a recursive call. And so we might have like the list 16, like 1, 2, 3. We can't just call fn on here, so we have to make a recursive call to like apply fn on the inner parts of it. And then we're gonna add that result to like the deep map recursive call made on like the remainder list, so the cooter list, which is 3, and that might end up to be like 9 if the function was like square. And then that deep map recursive call like right here might value to like 1, 4. And we're gonna add that back in to become like 1, 4, 9, with like 1, 4 being like a nested list. And same with it feels like a number. We would just since it's a number, we can just apply fn on this, so this would become 4, and then we would add it back in to become the list 4, 9. And yeah, that's kind of all of deep map, and make sure to let me know if you have any questions.